Welcome everyone. Today we are going to start our GATE session. I am Dr.M.NALINI, Associate Professor, Department of CSBS, SA Engineering College. Today we are going to see about algorithm subject GATE related topics and questions. So first we are going to see about the performance analysis in algorithm. So we know algorithm is what? It is a step-by-step procedure and we are going to execute, but all the algorithms are good, or how we will say that which algorithm is best. So that performance analysis is based on how we are going to measure. That alone we are going to see today. So the performance analysis, the main point, we are going to check whether the algorithm is executing in, it will take how much time and memory. Based on these two metrics, we are mentioning that the algorithm is good or best or worst. Like that we are going to make a decision. So it will be taken less time and it will be taken less memory space for the execution, then we will say that the algorithm is good. So less time and less memory means how we are going to evaluate that, what is the measure of the time and memory. So first we are going to see about the space complexity. So what is space? The memory space we are telling as in space complexity here. How much space the algorithm is occupied to execute and produce the result. Based on that we are telling as in that is space complexity. Here we have three types of spaces we are going to use for the algorithm. One is the instruction space, another one is the data space, another one is the environment space. So instruction space is nothing but it is the executable program. For one program is going to execute, for that how much space is required, that is we called as an instruction space. Next, data space. Data space is nothing but the algorithm is going to execute, right? For that we are using some of the data. We are going to store, after that we are going to execute. So for that how much space we are going to use, that is data space. Next, environmental space. Environmental space, for the algorithm we are executing, we are using some platform for the execution. We are going to set up some settings for some packages or something else. So that is we called as an environment space. So based on all these kind of spaces, how much space one algorithm is occupies, it is taken less space, then we will see that the algorithm is best. So next is the time complexity. So that is also very important. We are also running over the time alone. We can able to earn money, space or everything, but time we can't able to get it back, right? So that the time complexity is very much important. So if the algorithm takes less time to execute the big data set, we called as that kind of algorithm is best. So how much time it will be taken to execute for this much data, based on that we are going to evaluate. So here the space complexity, we have two types of space complexity. First one is the constant space complexity, another one is the linear space complexity. So from the name itself you can understand what is the constant space complexity. The space we are taken as it is a constant. Why we are telling as in constant? It will be never change, so that we are telling as in constant. So see here with the example as int square int a, and it will be taken the function, it will be performing as multiplication a star a. So this is the example we are telling as in constant space, because here we are given one variable. The variable, it will be occupies only this many bytes. That will be never change. It never taken extra bytes space. So like these kind of things we called as a constant space. Next, the linear space complexity, because before that we seen the constant space we are using only one or two values. In that value we are allocated one space, 2 bytes or something else. In that byte alone we are doing calculation and we are storing, and like that we are using the space effectively. In linear space complexity we need to deal with multiple numbers. For that also we need to fix the space, right? Particular space. Within the space alone we are going to use. So how much space we are going to define? For into 2 bytes we are defined, but we are dealing with n numbers. How we will define? So here also we can able to define the space, like 10 bytes I need or 20 bytes I need, like that we are mentioning. Within that space we are going to utilize the space effectively. That is we called as an linear space complexity here. So see this, here we are using the loop concept. In the loop concept, how many space we are taking for each and everything, that here we are mentioned. So for the assignments we are using 1, and for the loop statement we are using 1, and the loop execution we are using 1, and how many times the loop is executed, for that we are using n. So 1 for initialization and n for the number of time it will be executing, and the remaining for the storage of the value, and the remaining for the increment to be executed. So likewise we are fixing one linear space, that is we called as a linear space complexity. So next we are comes under time complexity. So time is very much important, so we need to fix the time also. So time means in algorithm what kind of time we will take, and so the compile time and execution time, like this kind of two time will be there. So the calculation of compile time plus execution time we called as, that is a time complexity taken time. So here we will taken how we are going to measure this. For the algorithm heading and all we are not taken anything, because for that we are not given time for that. For the braces also we are not calculated and we are not reading, so for that we are not wasting the time. For the expression, so what is the work we need to do, that expression alone we are reading, and we are getting consume time for that execution, so that we are mentioned for that as 1 the value. Next the loop execution. So how many times the loop execution, that many times the time will be increases. The loop is executed 100 times, based on that it will be increasing. The loop is only going to execute 10 times, so there is definitely the difference will be there, because 10 times will be executed in 10 milliseconds, 100 times will be executed in 100 milliseconds. So definitely 100 times loop means it will be executing, it will be definitely increasing, that alone they are telling here. So in here the time complexity also, constant time complexity, variable time complexity, like two things will be there. So in the constant time complexity they are telling us, see here the variable we are initialized, only two variables here we are dealing. So we are going to do the calculation for addition a plus b. So the constant time, only two variables, so immediately they are going to complete the calculation, so that we will say that this is a constant time complexity. Next the linear time complexity, it will be varying based on, because this is we called as looping. So loop means based on the condition we are given input with the 10 values, means based on that the loop is going to execute 10 times. Here we are given as input with the 100 values, means it will be executing 100 times. So linearly it will be dependent based on the input, right? So how many times the loop is going to be executed. So based on that they are telling here with the values. So already I told you, for this we are not taken anything count as a commands reading time, and the assignment statement we will taken as an 1 as a time calculation, we will taken as an 1 value, and the conditional statement reading and execution time we are taken as an 1 value, and loop condition how many n number of times it will be executed, that we called as an n plus 1 times it will be executed. And the body of the loop, how many steps will be there in the loop, that is we called as an n steps. So for this example here we are mentioned that they are taken as an algorithm sum of a comma n, and they are initialized the value for the sum, and they are taken as then for loop I is equal to 1 to n. After that we are going to add the value and going to store it into the sum, and they are going to return the value. So for this, for the assignments we are not taken any timing. So 0 we are mentioned, for braces also we are mentioning as 0. Next for the statement, initialization statement we are mentioned as 1. After that for see here the for loop, first for loop we are mentioned as 1. After repeatedly we are going to use that for loop execution n time, so that we mention as n plus 1 here. Next for the assignment, after adding two values we are going to store it into s, that is we taken as 1 here. How many times we are going to do add, so that we are mentioned as here as n. See here as after that the final result we are going to be written into s, so that this one here also the final value alone we are going to return, that is we mention as 1 here. So totally we are taken the value as 2n plus 3, the linear time. So like this kind of way we will define the time complexity before that, and we can able to fix it, that is we called as a linear time complexity. So after the time complexities we need to know whether how we can analyze whether the algorithm is best or worst or average case. So for that we are having three cases: worst case, average case and best case complexities. For which kind of algorithm we called as in worst case here? For T of n is the maximum time. One algorithm is taken for the maximum time for the execution, that is we called as in worst case. For any input I am given to that algorithm, definitely it will be taken 3 minutes for the execution. Like that we have ensure means that is comes under worst case. Average case means that is expected time. Like that kind of execution we called as an average case. So if I am given all inputs, but it will be taken only 1 minute time for the execution, expected time. Like that it will be given result means that is comes under average case. For best case, so best case the minimum time. So it will be depend on inputs. If any inputs I am given, within less than 1 minute it will be executing. It is very fast. Like that kind of algorithms are considered the best case. So all these are having the size of the input as n, but what way we are given and what is the type of the algorithm, based on that this case will be differ. So the complexity we are going to be ensure based on the storage and time growth functions. So based on the size and time growth we will ensure the complexity. So here we need to analyze the algorithm how it is. After that only we can able to see that is best case or worst case or average case. For that how we are going to be define, how we are going to evaluate, that we are going to see with the analysis of algorithm. So our algorithm we are going to be analysis based on what? The execution. So the running time and the memory management. So how much time it takes to run and how much memory it is occupied. So based on that alone we can able to say whether the algorithm is good or best or worst, right? So the running time is depends on how many number of inputs we are given and what is the computer and what is the speed and what is the space. So all these things are taken care. Based on the running time will be differ. So the running time differ on the speed of the computer. Next the programming language. So we are comparing with the Python and C program, we know the difference, right? So next on the compiler and translator. So the C program having compiler and if Java we are going as a translator. So likewise we have two combinations means it will be comes under fast. For one combination means it will be comes under slow. So based on that running time will be differ. So we are implementing the algorithm in which platform and which computer. Based on all these factors also our accuracy will be differ. That is they are telling here how to analyze all these factors. So for that factors analysis we define the notation as asymptotic notation. So this asymptotic notation is nothing but this is the mathematical way of representing the time complexity. So how much time it will be taken, that we will ensure here. That kind of notations we called as asymptotic notation. This asymptotic notation mainly taken care of the running time of the algorithm in terms of each and every functions or else otherwise in the statements. How much time it taken to running, that is we are telling here. So here the function behavior is very important. So based on the function alone it will be taken somewhat more time for the execution, right? So here they are telling that one. In the asymptotic growth rate, so the function is executing and the value growth how it will be there, it will be there in the upper bound or lower bound or middle bound. Based on that we will see whether if it is best case, average case or worst case. The growth rate based on the time and memory space occupy it. So the growth will be with the same rate or growth with the slower rate or growth with the faster rate. So based on these three rates we will define with three kind of notation. One is the big O notation, another one is the big omega notation, another one is the theta notation. Right, so first we are going to see about big O notation. So in the big O notation it is very slower rate we have. So it is taken less than compared to the remaining thing. So this is taken as an worst case complexity because this is taken as more time for the execution. They are saying here we are using two functions, one is the f of n and another one is the g of n. So f of n is the given input function and g of n is the time taken function, how it will be taken and executing. So this is the formula we are given as f of n is less than or is equal to c of g of n. We will say whether this complexity comes under big O notation. This comes under only worst case time complexity. Worst case means what? Already we seen it will be taken maximum number of time, that is we called as an worst case. So see with this example here what is present, the function. What is the function we are given? So see here the time taken duration g of n. So always the g of n is the upper bound compared to the function whatever we are given. So like this kind of way we are getting answer for all the times the algorithm taken too much time, that is the meaning. So like this kind of results we called as an big O notation. So this x-axis we are taken as n is the number of inputs we are using and this one is the time we are telling. So f of n function execution we are taken how much time. So based on that we are going to calculate. So for this example we are taken as f of n is equal to 3n plus 2 and g of n the n number of inputs they are mentioned as n here. So the formula is f of n less than or equal to c of g of n. C is nothing but here it is a constant value. So f of n function we are going to substitute here as 3n plus 2. So 3n plus 2 is less than c dot n. G of n instead of this g function we are taken as n alone here. The c value constant value we are taken as in 4 here. So we are substitute into this equation and we are getting the answer as instead of n we are mentioned as 1. Okay, for first we are taken as n is equal to 1. So 5 less than or is equal to 4. So this is false. Next we are taken the next iteration n is equal to 2. See here we are substituted, then we are taken as an yes less than or is equal to 8. So this is true condition. So based on that I am telling that the function given here for the f of n is equal to 3n plus 2 and based on the big O notation f of n less than or is equal to c of g of n, it is comes under the worst case complexity. We can easily understand based on this evaluation. So next we are going to see whether that is omega notation. So this is we called as an omega notation. This is very faster rate and it is greater than compared to others. This is the best case complexity. We mentioned that best case we seen right minimum number of time taken for the execution. I also said that less than 1 minute. Like that kind of execution algorithms are comes under omega notation. So here we are taken the formulas f of n is greater than or equal to c of g of n. So here already I told you c is the constant and n is the function input value. If it is lower bound and it is very best. So see in this diagram the f of n, this is the function, but it will be executing as a second less time, that is lower bound. For always the g of n is comes under lower bound of the f of n. So like this kind of result we are getting, that is comes under omega notation. You remember that for big O notation what happened, g of n is a upper, but here if it is a lower, so that we are telling us and this is the best case. So the same thing they are taken here as 3n plus 2 is the f of n function and we are going to execute the result. F of n is greater than or equal to c of g of n. So we are going to substitute this value here. Here we are taken as the constant value as 1 and the n value as 1, and after we are substituting f is greater than or equal to 1, that is the true statement. So definitely it is comes under the value of omega of g of n. Next theta notation, this is the third notation. So this is like an average case. So here we are taken same rate and it is very equal, that is they are telling here. Here we are taken the formula c1 of g of n less than or is equal to f of n and less than or is equal to c2 of g of n. If it is c is nothing but here it has constant value. If we are taken as in two constant boundary values and we are checking with the function notation, we are getting answer like this. With the example we can easily understand. So the function will be there here if it is will be in the upper bound and if it is in the lower bound based on the case. So that we are telling us it is an average case complexity. So what is the value we are taken, based on that we can easily say whether if it is an upper bound or lower bound. See here we are taken as then c1 value as 1 and c2 value as 4. So c1 value is comes under upper and c2 is comes under lower. So we are going to substitute with the same value 3n plus 2. Instead of n we are substituting n is equal to 1 and here we are substituting n is equal to 2 and here we are substituting n is equal to 3. Then what is the answers are coming? So 2 means 2 less than or equal to 8 and less than or equal to 8. So c1 we are getting 2 and c2 we are getting 8. The function value is 8. So it is true. So here for n equal to 3 the c1 value is 3 and the function value is 11 and g of n value, c2 of g of n value is 12. So this is also true. So that we called as this is comes under the average case complexity. So with the example now we are going to see whether the order of n squared. These are all some of the gate questions. So order of n squared is the worst case time complexity. So among the given options it can represent order of n or order of 1 or order of n of log n. That is they are asking. So already they are given the time complexity value is order of n squared and they are said that is worst case. Already we know because order of n squared means multiple times, that is the greater value n squared times it will be taken throughout the execution, so that we called as an worst case here. So here what are the things are possible, what they are telling. So among the given option it can be represented on which kind of option. So order of n squared is what? It is like multiple times of n. That is only we called as an order of n squared, right? So this will be comes under inside of order of n into order of n only we call it as order of n squared. Order of 1 also comes under inside of order of n squared. Because we are substituting n is equal to 1, it is comes under order of n squared only. So order of n into log n. So that also very smaller value compared to order of n squared. Order of n squared only it will be greater value compared to order of n into log n value. So for all these answers are coming. So all the above is the correct answer. See, all the above will comes under the answer for this question. So next we are going to take what does it mean when we say that an algorithm X is asymptotically more efficient than Y. When we can able to say X is more efficient compared to Y, we can able to say only if it is big or if it is fast, if it is large. So which one? Here we have X and Y. So yes, X is the biggest one, and if it is largest one, and if it is greatest one, then only we can say that X is the efficient compared to Y. So what is the answers here present? X will be better choice for all the inputs. எல்லா inputsக்குமே X better choice இருந்தா முடியுமா? X ஓட greater than values எல்லாத்துக்குமே better choice இருந்தா முடியுமா? So முடியாது. So this is not coming. So next X will be better choice for all inputs except possibly larger inputs. அப்ப smaller inputs it will be not suitable. அப்படினும்போது this is also not comes under. So next Y will be a better choice for small inputs. We are talking about X alone here. What is the efficiency? So efficiency means how it will be executing, how the value is better. So what is the third one? Sorry, second one. X will be a better choice for all input except possibly small inputs. For all the inputs, because X value is better value compared to all the small inputs. Instead of all the big inputs, it will be given because of it is very fast and it is very large. So that it will be providing answer for all the except small inputs. It will be given possibly large inputs. So that we say that X will be a better choice for all inputs. So now we are see the answer as X will be a better choice for all the inputs except possibly for the small inputs. Next, what is the time complexity of the below function? So how we are going to find the time complexity here? How many looping concept will be there here and how many functions will be there here? Based on that we will going to calculate whether the time complexity. Here we are using only one function, right? Only one function will be there, but how many loops will be there? We have two loops will be there, right? So one is for loop, another one is the while loop. Two loops will be there. So two loops means what is the time complexity? Usually is coming two times will be executing the loop, so the order of n squared will be coming, because one loop it is called as n time, another one loop is called as n time, so order of n squared. So order of n squared is right answer? No, not like that. Why we are saying that order of n squared is not a correct answer? See whether here what is the initialization. Before for we are given the initialization is I equal to 0 and j equal to 0 like that, but after execution of the for loop we are coming into while loop, right? If the condition is true, next we are coming into while loop, but before we are coming into while loop we are given any initialization or any value we are going to change, then only we will consider as that is separate kind of execution. We are taken as order of n time, otherwise both are comes under same execution only, same time only. So we can taken as treated as only one n number of execution. We are here we are assigning anything for j is equal to 2 or something else with the different assignment, that alone we are taken as a separate execution. So these two are combinedly executing, so we will taken as that execution as order of n alone. So now we will see whether the answer is what? Yes, order of n time it will be taken to executed. If it have two loops also, only n time it taken to execution. Okay. So now we will taken as what is the question? Consider the following two function. What are the time complexities of the function? So here we are given two function. Last example we see only one function with two loops, right? So here we are having two function and what is the complexity? Here the complexity how we will taken to the calculation means what is the function will be there inside. So based on that we will taken as the time how much it will be taken. So here function 1, function 2, inside the function 1 what is the time we are taken as here function 1 of n minus 1. Here in the function 2 we are taken as the time of what? Function 2 of n minus 1 plus function 2 of n minus 1. So based on these values alone we are going to calculate. For this value calculation, based on that the time will be increasing. So what is the first answer present here? Order of 2n for both function 1 and function 2. So both function and function 2, 2 power n, like that they are telling here. How it is possible? Here the calculation is different and here the calculation is different. So how it will be taken as 2 power n? So that is not possible here. So next taken as the value is order of n for function 1 and order of 2 power n for function 2. It will be possible. So function 1 they are telling us an order of n and function 2 they are telling us an order of 2 power n. Yes, because this is what the function n minus 1 time it will be taken to executed, but 2 star it will be multiplied with the 2. Next here what will be present? The function 2 of n minus 1 and function 2 of n minus 1 both will be comes in the same value, but we are adding and it will be taken as in twice the value. After that we are going to execution. So this is will come like that we are checking means, but here what will be the order of n is the function n, but see here the order of the function 1 have 2 cross. So here we are going to add only plus. So the multiplication value is compared to larger than the addition value. So compared to function 2 value, the function 1 value will be a greater one. So this is also not coming. So next we are taken as an order of 2 power n for function 1 and order of n for function 2. Yes, this is possible value because 2 star function 1 of n minus 1 only will be the greatest value compared to the function 2 of n minus 1 plus n minus 1. So now we are going to see whether which one is correct. So So see whether the order of n for function 1 and order of 2 power n for function 2. This is only the correct answer because of that is the multiplication. So this is the addition, but the answer is same. They are adding twice the times. So here they are doing the multiple value. So based on this we will get a clear idea about the time complexity. So here we are using two functions. So definitely we need to calculate for that each and every function separately. So for the function inside, what is the operations we are going to use, based on that alone our time is different for each and every function. For this function taken less value and for this function taken more value. Okay, thank you. Next session we will see in the next video. Thank you all.